we've constructed the square root function from the squaring function by reversing coordinates. This is what we do when we create an inverse function. When we invert a function, we reverse coordinates. Okay, now if this is our f of x function, so that f of x is x squared, and this is our g of x function, so g of x is the square root of x, then the square root of x ought to be the inverse of the x squared function. Well, to follow up on this idea, we calculate f of g of x, the composite. Now again, I mentioned that people did not do well with this on tests or in class. Again, we explained this in quite a bit of detail earlier in the semester, and I suspect lack of follow-up. I don't think it's that people aren't smart enough to get these ideas. People are plenty smart. I think it's lack of follow-up. So we got to do a lot of follow-up. Anyhow, we have f of g of x. Okay? What is that? Well, if f of x equals x squared, the question I asked in class, well, what's then f of aardvark? Well, it's pretty obvious that the x has now been replaced by aardvark, so we have aardvark squared. Okay, I like to use aardvark as a variable. Now, we're trying to do f of g of x. Well, if f of x equals x squared, what's f of g of x? Well, it equals g of x squared. Now, this is a step that people don't want to take. And I think one reason this might be causing people a little bit of a problem is that you don't want to interpret it step by step. You just want to go from, okay, f of g of x, what's that going to be? And try to get one expression there without thinking through the intermediate steps. In mathematics, you have to think through the intermediate steps, otherwise your answer is insecure and in many cases, with a high probability, wrong. Okay? So you have to say, what does f of g of x mean? Well, that means g of x squared. Now there's another way to answer that, but you know, we're going to go with this. Okay? So f of g of x is g of x squared. Now, that's one step. Another step, what is g of x? Well, right there, it's the square root of x. So we replace g of x with the square root of x, and we get that this is equal to the square root of x quantity squared. Now, what do you get when you square the square root of x? Well, everybody could answer that one easily. It's x. You square a square root, you get what you started with. Okay? So, this means f of g of x comes down to the very simple term, a very simple expression, just x. Okay, well, let's look at what happens if we do g of f of x. Okay, well, g of x is square root of x, so g of f of x is what? Well, x has been replaced by f of x, so we better replace this x by f of x. And that gives us the square root of f of x. Now we replace f of x with its expression x squared, and we get the square root of x squared. Now what's the square root of x squared? Well, I said it's x. Now that's actually not completely true. So I have to do a little caveat. This only applies if x is greater than 0, greater than or equal to 0. Okay? And why is that important? Well, if we don't make that restriction, we could square negative 5, right? Square negative 5, you get 25. What's the square root of 25? It's 5. It's not negative 5. Okay? So if you have a negative number here and do this, you're not going to get that negative number after you take the square root. Square roots can't be negative. Okay? Now, to fix that, we could use an absolute value sign around x, in which case you could put a negative in here. But since this isn't defined for negative values of x, that's not an issue. And also, we have to kind of think, okay, g of f of x works provided f of x is not negative, right? But of course, f of x is x squared, and x squared can't be negative, so we're kind of off the hook on that one. Okay. Now let me just do a little addendum here. It's not necessary that you even watch this, but so anytime you feel like tuning out, feel free to do so. But another way to do this f of g of x, I could say f of g of x, okay? Well, I have the choice of replacing g of x with the expression for g of x. So I could say that's f of square root of x, couldn't I? And of course, f of x is x squared, so f of square root of x is the square root of x squared, which equals x. Now that's just another path you can take to get from f of g of x to the expression for f of g of x. You can substitute for g of x right away, then substitute that into your x function, or your f of x function, or you can do what we did here, just, substitute into the f of x function immediately and get the g of x squared expression. And then the next step comes out the same as this one. And you could have done that with the g of f of x too. And if you prefer to do it that way, that's not at all a problem. It works either way. So if you understand what I did there, you can make your own choice.